Hi, good morning. Thank you for coming to this session about some practical steps. We've just heard John talking in his keynote about the kind of some of the theory around introducing automation into introducing security into our automation. And in this presentation, I'm going to be showing you some practical things that you can take away and start applying. So, first of all, how many people in this room consider themselves to be security people? Anyone? Couple of hands? Yeah, a couple of hands consider themselves to be security people. And traditionally, people who work in security are used to the idea that they know what code is running on what server. And they're used to the idea of things like patching to improve the security of their deployment. And suddenly they're faced with something like this, where they've got potentially hundreds of different microservices, and each of those microservices is potentially has dozens of instances, so there could be thousands of containers, and any of those containers could be running somewhere in this deployment of servers. We don't really know where that code's going to run. And it doesn't last very long. Traditionally, virtual machines would last on average 23 days. For containers, according to some research that Datadog did last year, the average container is only running in production for 2.5 days. So if you're kind of coming from a traditional security background and you're thinking about patching and you're thinking about how do I keep all these different instances up to date with the latest security patches, you're probably, your mind is blown by this, basically. You're thinking, how on earth can I possibly keep all these container instances secure? And certainly in the survey that Sonatype did last year, the vast majority of people agreed that they were worried about security when deploying containers. So if you're currently thinking, yeah, I am concerned about this, don't worry, you're not alone. And if you're not somebody who traditionally thinks of yourself as a security person, you're more of a developer, an operations person, maybe even DevOps, then hopefully this presentation will show you some things that you can do to bring security into your own practices. The key thing here is that, like everything else in DevOps, automation is your friend when it comes to improving the security of your containers. And what we're going to do this morning is look at the CI/CD pipeline, a super simplified version of a CI/CD pipeline, and we'll look at a way that we can improve security at every single stage. So whether you consider yourself a developer, an operations person, a security person, or some combination, there should be some things here that you can do. We'll start with code quality. Security begins with the quality of the code that we're writing. We'll look at some security testing, and we'll look at scanning dependencies for vulnerabilities. So the idea is that we end up building software that, as far as we can manage, is as free from security defects as possible. Then we look at deploying things. We look at the configuration of the machines we're going to deploy on, and we'll look at policies and configuration of the software we're going to deploy. So the idea is we're only going to deploy software that we're expecting to deploy with the configuration that we expect. And then finally, we'll look at what we can do with running software to detect behavior that maybe suggests something bad is going on. So let's start with code quality. Is XKCD a thing in Russia? Have you come across XKCD? Yeah? So this is a very famous XKCD where it basically talks about the possibility of SQL injections. And I'm going to basically show a demo. It was written by Justin Cormack at Docker. And this is going to show you this particular XKCD in action. So if I'm in the right, yeah, okay. So I'm just going to bring up, it's a very simple web application written in Go, and it has a database of students in it. And I have a little script to make my life easier. This script is just going to issue a curl request against this simple web application querying for, well, Robert, but with a bit of SQL injection going on. And the first time I run it, we can see, yeah, we had an entry for Bobby Tables. He is 23 years old. But if I run that query again, well, of course, it's not there because we didn't just query for Robert, we also dropped the whole students table. And that is SQL injection in action. It's a kind of classic thing that you can do wrong. And this is possible because the code does not protect against it. Security starts with the code that we write. So one of the things that we can do is use static analysis to check for this kind of problem where our code isn't protecting itself against SQL injections. And if I look at a Docker file, I've currently commented it out, so let me just add back in a step here that's going to run a utility called GAS, which is a static analysis tool for Go. There are all sorts of tools for different languages, but this is the language we're using today. And if I run a Docker build, we should find it's going to run that tool, and it's going to find the problem. It's found the problem in the code. This is the line it doesn't like. And because it found that problem, it's failed the build. So this is an example of using our build step to do some analysis on our code. We could also be detecting that kind of thing with code review. You know, 2 pairs of eyes on a piece of code can be really helpful. But bear in mind, that very first step where you write code can be a source of introducing security flaws. So it's a good place to introduce, or static analysis is a way of introducing automated tools into the process to help. So the next step typically in our CI/CD pipeline is testing. We write code and we compile it and test it. And we can also introduce security testing. We typically think about functional testing, but we can also introduce testing for security purposes. Because everybody loves a bit of regulations, you know, we've got some comics, some XKCD comics in this presentation, and we also have some rules and regulations. In this example, it's from the EU GDPR rules. And they suggest, but I strongly think you're probably going to use encryption. Encrypting any sort of GDPR related data is a requirement, essentially. So how are you going to make sure that your encryption is up to scratch? So we can use security testing, and again, I've got an example, and again, this is one that Justin wrote, where this one does take a little minute, so I'll talk about while it runs. And again, we're using our Docker build to run this test SSL tool. And what it's going to do is it's going to check the encryption protocol, or it's going to check the versions of SSL or TLS that this particular piece of code offers. And it will essentially, older versions of SSL are no longer considered secure, so they're no longer considered to be really encrypting data in transit. So this is checking, actually it doesn't like the fact that it offers SSL v3, which is now considered insecure. So it's kind of happy that it does offer TLS v1, and it will go through and basically check the security standards that we've built into this particular piece of code. This one takes quite a while, so I'm going to stop it in its tracks, but the idea is just using automation to look for things that might otherwise present an insecurity. So you can test for all sorts of things, not just functionality. You can also test for security-related issues. Right, the next step is vulnerability scanning. So this is looking for known vulnerabilities in the third-party dependencies that you include. I think most of us will end up incorporating some kind of package dependencies, depending on the language we're using. And with vulnerability scanning, we're looking at those dependencies and checking whether there are any known exploits or known vulnerabilities in those packages. Again, this is something that the regulations will require. If you're doing anything with payment processing and you're subject to PCI regulations, then you have to have some kind of system for assessing vulnerabilities. And I mean, they talk about requiring you to do security patching within a month. We're going to try and do security patching basically within 24 hours if we run our automated processes every day. So vulnerability scanning is looking for these, it takes the packages that are built into your container images and looks through them for known vulnerabilities. So it compares those packages to known databases of these existing vulnerabilities. And the idea here is that we're going to fail our CI/CD pipeline if we find something problematic. And we can do that by building the scanning into our pipeline. We also need to scan regularly. You can't just scan once when you build and then deploy and pretend there's never going to be any other vulnerability. Because unfortunately, code can have vulnerabilities in it, they just haven't been found yet. So there's this whole industry of security researchers out there who are finding the vulnerabilities like shell shock and heartbleed and all meltdown and Spectre, all these things that we've heard of. They're in code that has existed for a long time. We need to be able to scan on a regular basis to make sure that we find out if our existing code uses some third-party dependency in which a researcher has just discovered an important vulnerability. Another thing to bear in mind here is you can't scan for vulnerabilities in packages if the packages aren't in the image you're scanning. Which leads us on to an important anti-pattern. You must not, for security best practices, please do not SSH into a running container and change it. Treat your containers, always have your containers running from an immutable container image, right? Never SSH in and apply a new package. So instead, if we find that we've got a container with a vulnerability, we need to identify that container, and we know what image that container came from. We need to rebuild that container image and replace any running images of that container, which we can do because we just could blow containers away at any time we like. This is the beauty of kind of DevOps, immutable infrastructure, treating code as cattle, not pets. Has everybody heard that term, cattle, not pets? Not so many hands. Okay, so the idea of cattle, not pets is we used to give our servers names, a bit like we'd give a pet dog a name. And then if our dog died, we would be very sad. And if our server died, we would be very sad. But if you're a farmer and you have a herd of 1,000 cows, you don't give them all individual names. You kind of know that you have them and you know where they are. But if one of them gets sick, you know that the best thing to do is get rid of that cow. The cow is going to die. You're going to replace that cow with a new cow. And we need to treat our containers like that as well. If there's a problem with a container, we can shoot it in the head, replace it with a new one. That's how we should be treating our containers. So don't try to revive a sick container by SSHing into it and trying to make it better. Just kill it and get a new one. Right, so vulnerability scanning inside the CI/CD process. I'm going to show you a tool. This is a free tool that Aqua produces called Microscanner. So this is basically using our vulnerability scanning tool, which is a commercial product, but we make it available. The package vulnerability part is identical and available for free as Microscanner. And I have a version of it here. So if I look at the Docker file, that's basically exactly the same Docker file I've just shown you. And I can build this. I have to pass in a token. Hopefully I have internet connection and this will work. So it's basically collected up all the information in that, or the information about the packages installed in the WordPress image. And it's run Microscanner over that set of packages, which kind of fingerprints those packages, communicates with our cyber center, so kind of Aqua database of known vulnerabilities. And it comes back, it's passed, which basically means it's happy with the set of vulnerabilities. Now, the way I've done this, I've actually had this write the results in HTML form into a HTML file, which is currently inside the container image I just built. So I have a little script which will instantiate that container image just to copy out that that HTML file with the results. So I can run that. Actually, let's do. Okay, so that should have created this file msout, and I'm just going to open it again. This is an old version, but I will refresh it. There we go. That's the version I've just built. And it did find a few vulnerabilities, but they're only medium severity. And I can go and find out more about those, what each individual vulnerability is, and decide whether it's important for me or not. Now, if this had come back with any high severity issues, the Docker build would have failed. So we can automatically prevent a piece of software being deployed if it includes a high severity vulnerability by failing that build. And then that's going to, the fact that the build failed is going to be something that the developer hears about. They're going to get an alert that their build failed, and they can take action to maybe get a more up-to-date version of the library that doesn't have the vulnerability. Perhaps they're going to talk to their security team about, like, well, what should I do about this vulnerability? That can encourage the conversations between development and security. And we all know from John's talk and elsewhere that it's good for developers and operations people and security people to talk to each other. Okay. So that's Microscanner, that's vulnerability scanning. And results, okay. Now, what I showed you there was failing if we had a high severity vulnerability. You might have more complex requirements around, you might say, I want to whitelist a certain vulnerability, and we'll come to that later. But essentially, you might say, I always want to build the image, but I might not want to allow it to be deployed if it doesn't meet certain criteria, which we will come to shortly. But before we do that, let's talk about the configuration of our hosts. So we're going to run these images on some set of virtual machines, and those virtual machines are probably running Docker, and they're probably running Kubernetes, and they might be running some other code as well, although the smaller amount of code you can run on those servers, the less vulnerable they are to attack, because it's a smaller attack surface. But if we think particularly about the Docker and Kubernetes code that you're almost certainly running on those servers, there are some guidelines by, has anybody heard of the Center for Internet Security? Few hands coming up. Okay, so they're an organization that produces, they call them benchmarks. They're like specifications of how you should configure software for best practices in security. And there are There's a benchmark for Docker, there's a benchmark for Kubernetes. I'm actually a co-author on that Kubernetes benchmark. And it's basically 200 pages of telling you how you should configure Kubernetes, like what all the different settings should be and why they should be like that. So there's a tool that I am a maintainer of called KubeBench, and this is essentially automating running those tests, so checking whether your configuration matches the CIS guidelines. So am I in the right screen? Yes, this is the right screen. Right, so this just little script is going to run KubeBench on a little Kubernetes cluster I've got running here. And it found a whole bunch of problems. If I come up here, this is the sort of summary of problems that it found. I've just had it run kubelet tests, and we can see these first three things that have failed. Let's have a look for one of those. I'm just going to look for the first one. So if I look for my running kubelet, which is, I'm pretty sure, here, and I could just grep also for, oh, I need grep. Now privileged. So this is the process running on this node for kubelet. I'll make that a bit bigger, I think. And I've got it configured to say, yeah, allow privileged containers, that's fine. Well, it's not really a good idea, and the benchmark tells us, actually, you should have that configured to false. You would be much better off from a security perspective if you don't let people run containers with the privileged flag. So there's a whole set of things that the KubeBench tool will identify for you. Not all of them are necessarily going to be, like some of them you definitely would want to address. You might have reasons not to comply with every single one of these guidelines, but if you do follow all these guidelines, it will let you know if you've got things like an open API server that anybody could send commands to, an open kubelet API which anybody could send commands to. So this is a good tool for making sure your hosts are configured in a secure manner, or as secure as they could be. Okay, so KubeBench. Right, so I mentioned earlier the idea that when you come to deploy your artifacts, we've got these container image artifacts. We think they are free of vulnerabilities. We think they have been through static analysis and testing. So as far as we know, they are, well, secure. As secure as we think they can be. And we want to make sure that we're only running those images, the ones that we built. And we also want to make sure that they're only running with kind of the configuration, the permissions that we want them to have. So there are a few ways that you can do this kind of admission control, checking whether or not the images that you're about to deploy are okay. You can have admission controllers in Kubernetes. You can also have commercial tools. Aqua is one of them. Other commercial tools exist. Admission controllers you can write yourself. There are various interesting admission controllers available open source as well. And they can do lots of interesting tests. So essentially what they're doing is, for some definition of bad images, don't let bad images actually get run in your cluster. So that could be looking at the vulnerability scan output, looking at those results, looking at all the vulnerabilities that were found in an image and saying, is that okay? It could be as straightforward as, I'm not going to deploy any images with high severity vulnerabilities. Or it could be like much more complex and say, well, if it's this particular CVE in this image, then I'm going to whitelist it because I know that in my particular environment it's not a problem, or it's a risk I'm prepared to take. Or you might have much stricter rules. You might say, I'm not going to deploy with any medium severity issues, any medium severity vulnerabilities that are found. So you can make kind of complex rules around what you consider to be acceptable, what your policies are for the vulnerabilities you'll allow. You might have policies around the base images that containers have to be built from. So it's pretty common to see organizations saying, everybody who's going to build Python code should be building from this particular base image because we've looked at that base image and we are happy with all the dependencies that are included in that base image. And everybody who's going to write node code should be starting with this base image. And you can have those rules, but ideally you use automation, you use some kind of admission controller or some kind of scanning tool to say, I'm only going to allow images if they match those rules, and I'm going to check them in an automatic way rather than just culturally or through code review. You might want to check that you're not deploying containers that have sensitive data, and in particular, I mean things like the credentials for your databases. You don't want those to be baked into the image. There's a whole 20-minute talk we could have about why you don't want sensitive data baked into your image. And I wouldn't be surprised if that isn't something Seth talks about later, to do with how you can get sensitive data to the code that needs it, but without baking it into the image. So no passwords, no credentials, no tokens, nothing like that. You might also want to be able to validate that the image you're deploying is genuinely the image you expect it to be. It's the one that you built, that it hasn't somehow been intercepted and replaced on, between your Jenkins pipeline going, here's a build, and it goes to a registry, and then gets pulled from the registry into your deployment. You want to make sure nothing went wrong in the middle there, that nobody else has intercepted that image. So there are various projects. There's a Grapheus project, there's Notary, that are all around the idea of checking that the image came from where you expected it to come from. And you might also want to check that your images don't run with permissions that you don't expect them to have. So things like what capabilities they require. Or my personal favorite, which is checking that images don't run as root unless they really have to. So we will have a look at, some other things that we can do with privileges and root in a second. We also might want to check that we're not passing in the privileged flag. The privileged flag is possibly one of the worst named flags in the world of containers, because when you run a container, by default, unless you have done something to change this, by default it's going to be running as root, and root already has a ton of privileges. If you add the privileged flag, you also add kind of a world of privileges that your containers have no business having. Again, that's another 20-minute talk. Okay, so let's talk a little bit about how you can inadvertently give your containers more privileges than you expected to. Another XKCD that we really like. Not every container needs the ability to make a sandwich. So, I'm just running a container. It's an Nginx container. And if I'm root, but I did a rather peculiar thing here and a rather foolish thing here. I mounted the etc directory from my host into the container. And there was nothing to stop me from doing that. Now, actually, let me just stop that for a second. And who am I? I'm currently not root. And if I try to do something like add a password, add a user, I hope I'm not going to be allowed to do this, otherwise my demo will be less good. Yeah, okay, there we go. I don't have permission, bring that up a bit, I don't have permission to add a user. But I do have permission to run a container and mount the etc. directory. And let's just clear that. As we just saw, I am now root. And root inside the container is root on the host. So I could do something like add a user. Oh, I didn't spell attack very well, but never mind. And I can give it a password. And now, if I look at, well, I should be able to, etc. password. I might have to be the sudo. I don't know if I'm allowed to see this password. And we look for that attack. Yeah, I've just been able to add a new user. So as an attacker, if I was able to compromise just a regular Common or Garden Nginx container running as root, I am, and I'm just picking on Nginx for no good reason, I've got root privileges. And if somebody runs a container and they inadvertently, or for some reason they didn't, really think through, they've mounted a directory like etc., then, I can suddenly create users. That's a pretty significant security flaw. So you really want to make sure that wherever possible, containers aren't running as root, and that you're not deploying containers with things like a mount. I mean, unless there's a really good reason, that shouldn't be allowed. And you might use things like admission controllers or commercial software to check for that kind of thing. So yeah, that was a bind mount, so minimizing bind mounts, particularly for sensitive directories. Use the user directive in Docker files so that your images don't have to run as root, and avoid that privileged flag that I mentioned earlier, which is terrible. Okay, so we're kind of at the last stage of our CI/CD pipeline now. We've built the code, we have deployed some code, it is running. We're kind of already beyond the end of the pipeline, if you like. And we're running some code. And one of the nice things about particularly microservices is that it starts to be much more plausible to kind of model what expected behavior looks like. So if you've got a microservice that's supposed to do something like, let's say, product search, it totally makes sense for that microservice to communicate with your database to query products. Doesn't make any sense for it to be, I don't know, trying to send traffic to the internet, or trying to create users like I just showed in that demo a second ago. So limiting a microservice so that it can only do a certain set of functions is a really powerful security technique. So essentially we want to stop unexpected behavior, because anything that is not expected we can start to consider as a bit of a horror story. One of the ways you can do this is with security modules and, well, like AppArmor and SE Linux and setcomp. So setcomp is a feature that basically lets you restrict the system calls that a particular executable can run. And this is, it's kind of complicated to set up the profiles, but there are some really good default profiles. Jess Frazal, when she was at Docker, did some really good work to build a default setcomp profile that works for, like, 99.999% of containers, but prevents you from doing things like running ptrace. Like, there's rarely a good reason for one container to be able to run ptrace on another, on another process. So if you're using Docker, you get these default profiles, and they're actually really quite good sandboxing. In fact, I saw Jess talking a couple of weeks ago, and she was making the point that she has a site called contain.af, and it's got like a capture the flag in it that nobody has been able to capture, and the only protection she has is her seccomp profiles. So, that's kind of indicating that she's good at seccomp profiles, and B, using those profiles is probably a good idea. But unfortunately, they don't get automatically applied if you're using Kubernetes. Hands up who's using Kubernetes. Okay, quite a few of you. So does this look familiar to you at all, these kind of annotations? Anybody seen those? A couple of hands, yeah. So you want to look this up afterwards. By default, just apply those default Docker, seccomp, and AppArmor profiles unless you know better. But if you don't know better, this is a good starting point. And unfortunately, you have to apply them using these pod security policy annotations. Sorry, there had to be some YAML somewhere. Another thing I just want to show you is something that we do at Aqua around restricting container activity. So while you can restrict at the system call level and the file access level, that's quite complicated. What we can do with tools like Aqua is define the expected behavior in terms of the executables that are allowed to run, and maybe the user IDs and the network traffic that a particular container image is associated with. And then we can either prevent that behavior from happening or warn if we do something outside of that. So I have another thing. Let's check this is the right one. Yeah. So I've got an Nginx container running, and this, I'm going to close this window. And yeah, here's my Aqua log. Right, so hopefully this Aqua can see that Nginx container running. And it's applied a profile called Nginx October 2018. And I can go and look at that profile, and it will show me a few things that are allowed or not allowed. But in particular, it's saying there are only, basically, the only executables you're allowed to run inside this container is Nginx. Anything outside of that is unusual and probably a bad sign that perhaps this container is being compromised. So let's pretend we're compromising that container by execing into it and running a shell. So this is simulating the idea that somebody has compromised a container. Could be anything. I'm just using Nginx as an example. And maybe I do something like, well, first of all, as an attacker, I might want to find out what user ID I am. So I find out that I'm root. And I can start looking around this container and see what's accessible to me. Now, inside Aqua, we should, and I think this has already got it, yeah. So we can see that was me running ls, and we've detected it and said, oh, that's unauthorized, that shouldn't be happening. That should be, this log is also going into your seam log and could be triggering some kind of alert to say something unusual is happening here. That's the ls as well. This is going to be the who am I that I ran before. So we've detected these executables that we don't expect. And we can go even further than that. We can say, let's make this profile, currently it's auditing, and I'm going to make it enforce. And I need to save that. So now that should mean that if I try and run those same things, I just get permission denied error. So if I've compromised a container but it's protected by our tool, trying to run something outside of the profile in enforce mode, it's just simply not possible. Even though I'm root, how can I possibly, I'm still root, I didn't change identity, but we've been able to prevent this unexpected behavior from happening. Nginx is still running, but I can't do anything out of the ordinary. So not every... ooh, that's exciting. I think I've managed to crash my machine. But that's good because I was right at the end. It's fine. Yes, I've never had that happen, but fortunately that was at the end of my last demo. And all I was going to show you, we'll see whether this comes up in time, to basically sum up and say, I think I've shown you how it's possible to have, sorry, I need to type in my password. It's possible to have some kind of security measure at every step along your CI/CD pipeline. You can introduce code review, you can introduce static analysis, you can have security testing. Vulnerability scanning. If you do one thing, if you take one thing away from this talk, please do vulnerability scanning, because the number one reason why containerized deployments, well, actually, why any software deployment gets compromised is that it's running with a defect that's already known. So vulnerability scanning can save you from that. We talked about making sure that your configuration is, your hosts are configured, your VMs are configured correctly. See whether we restore the right pages. That's the one I want. Yeah. Loads of things that I don't want to run. Yeah, we talked about making sure that your your hosts are configured correctly, and using tools like KubeBench to validate against the CIS spec. We talked about using admission controllers. We've talked about using the seccomp profiles. That's the second thing. You know, if the first thing is vulnerability scanning, the second thing is seccomp profiles, because they're super easy. And finally, I'm going to skip to the last slide if it loads. Oh, I've got one last XKCD for you, so I should show you that. Come on, Google. Come on. Okay. I've given you a ton of security advice. It might be good advice. I think it is good advice, but it's up to you to make your own decisions about what security is appropriate in your organization. There will be people out there giving you bad advice, but you know, there's lots of good advice out there, and as a community we can help each other get best practice and automate our security. So finally, a few links for you. So the first two are links to the tools I showed you, Microscanner and KubeBench. And the last one is a link to No Meltdown. Those demos that I showed you that Justin Cormack wrote, they're actually in that deployment because they came from a talk that we did together called Don't Have a Meltdown. So if you want to run those demos for yourself, you can find the source code in that repo. So with that, I think we've probably got maybe a few minutes, so we can take some Q&A now, and I'll also be outside somewhere that I haven't yet identified. Yeah, good. Thank you very much. I think I may have hit the limit on how many virtual machines you can run on a MacBook Pro before it crashes. I see your question. Yes, great.
I'm here with Mike. Hello.
Hi.
Oh, it's very interesting hearing you and your way to providing some security in containers. But in developed world, we have some open source utilities that can prove our system, say about some vulnerabilities in our package or maybe systems. Do you know any additional open source?
So open source tools specifically for vulnerability scanning. There's a couple. There's Anchor and there's Quay. it's actually one of the reasons why we made Microscanner available. So the problem with vulnerability scanning is it's very easy to find false positives. And what happens is there's this thing called the National Vulnerability Database that has a big list of all the exploits that have been discovered, and it maps them to a version of software. But it doesn't take into account any patches that have been applied by the different Linux distributions. So, for example, if you're using Debian as your base image, then they will very often have security. They won't necessarily update the version of a package, but they'll apply a patch to an older piece of software. And they keep track of which of those, which vulnerabilities they've patched. But that information isn't in the NVD database. So if you don't have knowledge of like not just the NVD, but also all of these different distributions and all the different vendor patches that have been put in, you're very, very likely going to get false positives. If you just look to the NVD, you're going to get false positives. So the open source tools out there, what we heard from vendors was that one in particular, there was a big European retailer who basically said to me, I have completely given up with vulnerability scanning because I just get so many false positives, I don't know where to start, and it's just creating a headache that I can't solve. And we knew that because we're putting a lot of work into avoiding false positives where possible, we have like a team building this for our commercial customers, so we decided to make Microscanner available for free. It's not open source. So there are solutions out there that are open source, like Quay and Anchor, and they may be fine for your use case. The reason why we made ours available was to encourage people to do vulnerability scanning rather than just sort of maybe use some tools and go, I just can't stand this any longer. We wanted to make them a good quality tool available. So it's exactly the same database as our commercial tool, but it doesn't do all the other things like scanning for sensitive data or scanning for malware, configuration checks and things like that. Does that answer the question? Yeah, no, Anchor and Quay are the two that I can think of. Okay? Yeah. Another question down here at the front.
Okay, we have like 2 minutes left, so real quick, and after that, Liz Rice will be able in discussion zone number 2. So,
thank you very much for your keynote. Everyone is speaking about dependencies, vulnerabilities, but not many people understand what exactly it is about. Do you have some kind of obvious example of security breach caused by dependency vulnerability?
Yeah, the one that springs straight to my mind was Equifax, which was a result of a vulnerability in a structs library, and somewhere I've got a demo of how that can be exploited. I've done that in a talk before. And there was maybe a 3-month window between the particular vulnerability being published and the Equifax breach happening, so they had 3 months to patch that software. Okay. Are we out of time? Yeah?
Oh, well, like 60 seconds, so Klaus, thank you so much, Liz.
Thank you very much.